Like I said, we're going to look at some more of those factorials. So here we have 13 preschoolers and we need to line them up in line. If you're the line leader, you can't be the door holder too. Everyone's going to be in order one at a time. So I have 13 choices for the first person, the line leader. After I choose that one, there are only 12 students to choose from to be the second in line, or maybe the door holder, whatever job second in line is. And this idea of once I choose one, there's one less person, is going to keep going until I've done every single student. Now, that gets really old to write out and type in. So that's why we have that shortcut that I was talking about. When we decreasing by one and we go all the way down to the number 1, that's called 13 factorial with that exclamation point that we found in the calculator the other day. We can type that in, and this is going to probably give us something huge here. Let me get back to where I was at. Typing that in my calculator. That's going to give me that huge number, 6,227,227,020,800. And that's that factorial, and I've got that written up down here. It's where we're going to keep subtracting 1 until we get all the way down to the number 1. It's all the natural numbers less than whatever I use, and in that case it was 13. You don't ever have to use it, but it is an option if you don't want to type in all those numbers. Here's another one where we could use the factorial. John keeps the phone numbers of his 7 closest friends, 3 men and 4 women, in his phone memory. And he's going to list them with men listed before women. So we don't know how many ways that is. So for our men, there are 3 of those. So once we put one person's number in there, we're not going to use that person again. We're going to use, each one's going to be listed one time because that's the only thing that makes sense in a phone. And then the women, I'm going to keep multiplying, kind of like we did with the letters and the numbers. I'm going to multiply them together. It's always multiplying, and there are 4 of them. And you can multiply factorials together as well. So you can use either method. Type in either one, the first line or the second line. It's going to work out the same. And we're going to get 144. Then we've got that definition of factorials. Now we use this definition of factorials in what we call this arrangement of objects that look alike, or look-alike objects. They're also called distinguishable arrangements. So a lot of times you'll see this word distinguishable arrangements. And this comes up a lot with letters. If you think about like Scrabble or Word with Friends, all the G's look the same. So if you were to switch the G's around, you would still have the same word. So that's what we say they're lookalikes, or we cannot distinguish one G from another G. They're all the same. So that's why we have this little formula here. Now I'm going to add something to it. The formula really needs you to put parentheses around the denominator when we type that in our calculator. So on the top is the total number. In my case, they're going to be letters factorial. And the bottom, any letter that repeats, I'm going to make it a factorial. And that little dot, dot, dot in the K just means you can do this as many times as you need to. And I'm going to put those in parentheses. Your calculator really is not going to give you the right answer if you don't put the parentheses around there. So I'm just going to add that to the formula that my math lab uses. So this first example, the word giggling here, there's 1, 2, 3, 4, 5, 6, 7, 8 letters. So that's my numerator. G's repeat, 1, 2, 3, 4. So that's going to be a 4 factorial, and I'll label that. That's for the G's. And then the I's repeat, there are 2 I's. You can put a multiplication there. Some calculators force you to put a multiplication in between them, and other ones don't care. So it's usually the smaller ones that care that you put a multiplication. I would suggest typing this in all at one time. You don't always have to do that, but sometimes the numbers are so big the calculator can't handle them unless you do it all at once. So this is going to be 840. The next one works just the same, so why don't you guys hit pause, try the next one, and see if you get the same answer. It's much bigger than 840 though. right, coming back from pause, looking at this word mathematical, there are 12 total letters in it. And then the repeats, I'll try to color code them. M repeats 2 times. That was M. Let's see. A repeats 3 times. And T repeats 2 times. I guess I should label those. And remember, we're going to put that in parentheses. Some calculators need that multiplication, some don't. Up to you and like your calculator to see if that's something that you need there or not. You don't have to include the other letters. You can if you want to. There's one H, so you could put a 1 down there for the H, and the E and the I. You could put those letters down there if you wanted to. 1 factorial is just 1, so it doesn't change the problem. Most of the time we don't put that down there because it doesn't change the problem. It's more work. Typing this in my calculator. If you're not getting these in your calculator, I'm super happy to help when we're in class, as long as it's not like a test. But I'm happy to look and see what went wrong when you typed it in, or you can stop by office hours or any of the tutoring to get someone to help you type those in the calculator as well.